Welcome. You were born to be here. You're preparing for the AP Calculus exam, yeah? So get your notebooks out, get a pen or pencil to write with. This is math from the void, math coming at you out of nowhere. And today we're looking at a problem from the 1993 AP Calculus exam. You'll notice that this problem is listed and numbered for the AB exam as well as the BC exam. And that's because this problem is totally approachable from someone with AB level knowledge, and also because the tests have many of the same problems, literally the same problems. So this question would have been on the AB exam number 4, free response, and it would have also been on that same year's BC exam number 3. Okay, so the BC students, y'all look out when you look at this one. This should be pretty dang easy. Let's look at this function. Function is defined by an ln function. ln has some domain restrictions, so we're going to be on the high alert for that. And it's just a chain function. There's a sort of chain rule to it because it's a layered function. So 2 plus sine of x is on the inside. Now, remember that the domain of this, none of these questions specify the domain of this, but the domain of this, the inside of a logarithm needs to be greater than 0, strictly greater than 0. Well, let's work on how that's definitely true. And we're given an interval here. But let's work on how that will definitely be true no matter what the interval was. We know that sine of x is always going to be less than or equal to greater than or equal to -1, less than or equal to 1, which means 2 plus that is going to land us somewhere in between 1 and 3. So it's always going to be greater than 0. I guess we could say this. Always greater than 0. So 2 plus sine x is always positive, which means the ln of that is always defined. Now we are given an interval which is going to play into the idea of the absolute maximum and the absolute minimum. Recall that in order to figure out the absolute max or min on an interval, we use what some people will deem the candidates test. So the candidates for the absolute max or minimum are as follows. The only possible candidates that we need to consider are going to be endpoints and critical points. So critical points are where the derivative is equal to 0 or undefined. Endpoints are just the endpoints using the interval that they gave you. So from pi to 2 pi. Okay, well, let's check the actual value of these at pi and 2 pi. You'll notice that sine of x is the same value at pi and at 2 pi. So we have f of pi, which is going to give us ln of 2, because sine of pi is 0. So 2 plus 0 is just 0. And then the other endpoint, f of 2 pi, is also equal to ln of 2, because sine of 2 pi is 0. So that means that we have 2 points so far. ln of 2 is like, it's not really important what it is, but it's like 0.7-ish, 0.69 or something. So at pi, we would have a point here, and at 2 pi, we would have a point here as well, which means the graph, it's probably not going to go straight, right? The graph is either going to do something like this, or it's probably going to do something like this. Seems reasonable. Let's check for critical points. So, by the way, it's likely that these both are either going to be the absolute minimum, or that these both are going to be the absolute maximum. Or if it were to do some kind of weird sign stuff in between, maybe it's neither the maximum or the minimum. But I think it's a good idea that it's going to be this like kind of rainbow thing, or this kind of upside down rainbow shape. All right, let's find the critical points by taking the derivative. So f prime is equal to 1 over 2 plus sine times the derivative of the inside, which is 2 plus sine. That derivative is cosine of x. So if we put that all together, we get cosine of x over 2 plus sine of x. And this is only going to be 0. This can't be undefined because this bottom part will never be 0. This can only be 0 when this is equal to 0. So when is cosine of x equal to 0? That should be very easy. It comes from pre-calculus, some trigonometry basics. Every odd pi over 2. So we have like pi over 2, 3 pi over 2. I could put plus or minus because technically that's true as well. But remember that our interval is from pi to 2 pi. So the only one which fits in between there is going to be 3 pi over 2. That's where a maximum or minimum would happen. Now, which one is it, a maximum or a minimum? Do you know? I'm curious. Do you know? It's going to be a minimum. And that's because the sign of cosine goes from negative to positive at that spot. If you don't believe me, take a look at the unit circle. Remember that cosine is the x value on the unit circle. So from pi to 2 pi, this thing goes negative, and then it hits the 0, and then it goes positive. So it's definitely going to be some kind of a minimum value. Let's find out what the value actually is, though. So we plug it into the original f of 3 pi over 2. This is going to be equal to ln of 2 plus sine of 3 pi over 2, which is negative 1. Again, you should know these trig basics. Which is equal to ln of 1, which is 0. So that means that at 3 pi over 2, let's say this is pi, and let's say this is 2 pi, at 3 pi over 2, the graph actually hits that spot. So it probably does something kind of like that. And so this will be the absolute minimum value. Okay. We can say that it's at x equals 3 pi over 2. And then we can say ln of 2 is the absolute maximum value. And we're going to say that we're going to indicate that it occurs at x equals pi, comma 2 pi. It's not just occurring at x equals pi. It's the same y value, which is the highest y value in that interval, and it occurs at 2 different times. Okay, so that would give us full points. I'm just making sure that you know how to write your answers as well. They want to see it like that. Now for part B, find the x coordinate. Don't have to plug them back in then, of each inflection point. What is an inflection point? An inflection point is when the second derivative changes sign. Okay, it has to change sign. If the second derivative goes to 0 and then goes to, like if it's positive, goes to 0, goes to positive again, that's not an inflection point. It has to change sign. So let's find the second derivative by taking a derivative of the first derivative. Let's go. This is going to be the quotient rule. So we're going to use low d high, so 2 plus sine of x, times d high, the derivative of the top is negative sine of x, minus high d low, so minus cosine of x, times the derivative of 2 plus sine of x, which is also cosine of x, over the low squared, so over 2 plus sine of x squared. Let's simplify this a little bit. It's going to come out to be pretty nice. We're going to end up with negative 2 sine of x, negative sine squared of x, negative cos squared of x, and we're about to do something with that, over 2 plus sine of x squared. Now let's simplify this, because this here is the same as negative parentheses sine squared plus cosine squared, yes, which is just equal to 1. So on the top, I really just have negative 2 sine of x minus 1 over 2 plus sine x squared. We can kind of analyze this, all right? So we can analyze this. When does this equal 0 or undefined? The bottom is never going to equal 0 again. So the second derivative will always be defined. And let's see when this top part equals 0. If that's the case, then sine of x equals negative 1/2. Okay, and that's going to happen at x equals, if it's negative 1/2, that's going to happen at 7 pi over 6 and 11 pi over 6. Those are both in the interval from pi to 2 pi. Now, what about the sine value on those spots? Is it, or in between those spots, is it negative or is it positive? Well, you could just draw the graph. of negative 2 sine x minus 1. It's a very useful thing to be able to draw the graph. Okay. We know that it changes actually, so we really just need to know those x values, and those will be the inflection points. So technically you're done with the problem at this spot. But you guys know how much I like really explaining what's going on here and how to double check your work and stuff like that. So if we were to sketch a graph of negative 2 sine x minus 1, again, this would repeat after 2 pi, and we're really just mostly looking at this portion of it. What would the graph kind of look like? It would like go down, come back up, go up, come back down. That would be the negative 2 sine graph. The normal sine graph, like the positive sine graph, right, it would start by going upwards. It would sort of go like that. But since we have negative 2, it's going down first here. Oops. Something like that. So we're really just emphasizing this interval from pi to 2 pi. So like from right here to right here. Notice that it goes negative to positive. That happens at 7 pi over 6. And then it goes positive to negative. That happens at 11 pi over 6. Okay, so those are the x-coordinates. They just wanted the x-coordinates of the points of inflection. If they needed y-coordinates, they would have you plug it into the original function. In fact, let's just do that. F of 7 pi on 6. You wouldn't necessarily need to do this on the AP exam. You would have other things to get to. But since we're here, we have the time. I'm walking you through this. This is simply going to be ln of 2 plus sine of 7 pi over 6. Sine of 7 pi over 6 is negative 1/2. We know that here. So this is just 2 plus negative 1/2, or 2 minus 1/2, which is ln of 3/2, kind of the best we can do there. That's the value. And similarly, the value at 11 pi over 6 is also going to be ln of 3/2. So those are the y values if you needed the point of inflection. If they said the points of inflection instead of just the x-coordinate, you would need the full coordinates. You would need x and y. Okay? So that should do it for today from the void. I'll see you next time.